In this video, we're just going to go over some of the basic rules about exponents. You'll be using them a lot in this unit. And they generally fall into three categories. You have the product rule, the quotient rule, and the power rule. And then you have some other stuff left over. So I'm going to give you some examples of each one of these rules. If you're just looking for the rule itself, you can see it all in this column. Okay, that basically sums this up. But I'm going to give you some examples now if you want to see how these would kind of work together. So let's say we had 2 cubed times 2 squared. Okay, well, what would that be? And by the way, you can actually rediscover these rules. You don't have to memorize them. If you want, imagine I wrote something like this. 2 times 2 times 2. Okay, that's my 2 cubed times 2 times 2. That's my 2 squared. Well, how many 2's do we have? We have 5 2's. Okay, and you see that matches the rule of adding things together when you multiply. And in the example right below that, it's also called the product rule. Let's say we had something like, 3 squared times 4 squared. Well, that would be equal to 12 squared. Okay, that exponent distributes over the multiplication. So next example, quotient rule. I could give you an example like this. Say 2 to the 5th power divided by 2 cubed. And if you wanted, you could do this out manually, right? 2 to the 5th is 32, 2 to the 3rd is 8. You would get the same as if you subtracted the exponents. 2 to the 5 minus 3, so that's going to be 2 squared. And likewise, the other version of the quotient rule is if I have 4 cubed divided by 2 cubed, that's equal to 4 divided by 2 with a cubed on the outside. And that's just 2 cubed. Now, you'll probably notice at this point there are two things that are always going to be the same. Either the base is the same. See, I have a and a in this example, but different exponents. So either you have the base the same, or if the base is different, you have to have similar exponents. You're going to have one of those two things is true. Either similar bases or similar exponents. And if they're both different, there's not a whole lot you can do. You just have to leave it in that kind of ugly form. So moving on to the power rule. This one often gets confused with the product rule because people forget how exponents work. 2 cubed squared. Well, that just means 2 to the 3rd power times 2 to the 3rd power. Okay, so that's going to be equal to 2 to the 2 times 3. In other words, the exponents now multiply because one is raised to the other. And then this example right here, we've actually done this before. It's rational exponents, if you remember that. Let's say we have 2 to the, 6th power. And I want to cube root it. Well, that is the same as 2 to the 6 over 3. This one actually comes up quite a bit as you get into higher mathematics. Because oftentimes it's easier to work with exponents that are fractions instead of dealing with all these crazy square roots and cube roots and whatever roots. And in the last example, these are 3 very quick rules. You'll actually use these quite a bit in a graphing unit on exponents and logs that we're about to start. If I were to say something like 2 to the negative 3, well, that's the same as 1 over 2 to the 3. Okay, that negative in the exponent means you can flip it over as if it were an inverse or a reciprocal. And that's going to be equal to 1 over 8. And then, here, I'm tired of 2's. 5 to the 0 power. We remember this one, right? It's 1. And 5 to the 1 power, that's equal to 5. Okay, anything to the 1th power is equal to itself. Anything to the 0th power is just equal to 1.